Rhenium is in the same group as manganese in the periodic table, but quite surprisingly, it was only discovered in 1925. So my father was 15 years old when it was discovered. So it's a very recent discovery compared to many of the other elements. I think because it's quite rare and it is also quite hard to separate.
Rhenium. Let's look what the rhenium looks like. So this is a sample of rhenium. Okay, this is a very, very nice metal, often used in catalysis from the middle of the transition metal group. And here you see the very, very dark black coloration of this very, very fine wire of rhenium.
So I'd never seen a sample of metallic rhenium until about a month ago when I was given some as a present. So here's the sample. It's quite a nice silvery metal. And what's surprising is that it's really very heavy because elements low down on the periodic table are very dense. And we can demonstrate this by weighing it. Let me compare the rhenium with a pile of 5 American 10-cent pieces, 5 dimes. So this is half a dollar. And you can see this is bigger than that, considerably. So if we weigh the coins, you can see it weighs just a bit more than 11 grams, 11.3 grams, which is quite reasonable because they're made out of copper and nickel. And if we now take these off and put on the rhenium, which is a smaller lump of metal, you can see that it weighs more than 16 grams. So it's a really very dense metal.
Who gives someone a little shot of rhenium as a present?
So this comes from the managing director of a company called Lippmann, who make or supply rare metals. And he came to give me an interview for a magazine, and he gave me a sample of this element. So I was really excited. He gave it to me in this bag, together with the analysis of the element, and it's 99.9% pure. And inside is a piece of paper with the complete analytical data. I was really very excited, and especially because I was not expecting a present. We're always taught metals in the same group of the periodic table, like manganese and rhenium, are very similar. So I was expecting that the salts of rhenium would be very similar to the salts of manganese. But I was really surprised when I was told that the company also supplied a salt, perrhenate. So I already knew that the manganese salt, permanganate, had this terrific purple colour. So here you can see it dissolved in water, and next to it you can see the solid that's almost black. So these are manganese salts. So I was expecting a terrific colour from the rhenium salt, and the rhenium salt is a really boring white. This is perrhenate with rhenium in it, and the reason why it's white, which I understood afterwards, is because the colour comes from the energy of the electrons in the iron. And in rhenium, the difference in energy between the different levels for the electron is much bigger, so instead of absorbing visible light and looking coloured, it absorbs ultraviolet light, which we don't notice. So, big disappointment. Perrhenate is white. Rhenium, in recent years, has become an extremely important element for making aircraft engines, particularly jet engines in aircraft. And at the same time as giving me this sample of rhenium, I was given this object here. This is a turbine blade from the front end of a really quite sophisticated jet engine. Now, it's a used turbine blade, and you can see there's a large slot has been cut in it to stop people selling this used blade to be put back into jet engines. So this sits right in the middle of the engine, just after the combustion chamber where the fuel has burnt. So the temperature is very high, and this is spinning round very fast. So there are enormous stresses on this metal. The temperature is probably about 1600 or degrees centigrade or even higher. And most metals would just melt, or they would become so floppy they would stretch as they spun round. And this is made from a special alloy which has quite a lot of nickel in it, but the magic ingredient is rhenium that makes it stronger. But what I find particularly surprising about this is that this whole blade is a single crystal of metal. Because if you have a lump of metal, the weak part is between the different crystals that make up the lump. But if you grow a single crystal, it has no weaknesses and it's very, very much stronger. So this is an amazing piece of engineering, because if you look closely, you can see it's hollow. So they have grown a single crystal which has a hole inside so they can blow air through it to keep it cool, to stop it getting quite as hot as it might do otherwise. And so the lump of rhenium that I was given actually came from recycled turbine blades, because rhenium is quite a rare element, and once you put them in the turbine blades, when you service the engine, you get the turbine blades back and you can recycle the rhenium metal. And if we didn't do that, it would soon run out because there aren't very large supplies of rhenium. In the longer term, rhenium may have quite useful applications in a variety of solar cells and perhaps as catalysts for splitting water into hydrogen and oxygen. But at the moment, the major technical application is in making these special alloys. It is called rhenium because it was discovered in Germany, and the rhenium is derived from the name of the river Rhine, which flows through Germany.
There are other rivers in Germany, though. Why'd the Rhine get?
I have no idea.